everyone. Thanks for watching Science at Home. I am Tesha Dampier. I am a scientist at 3M. By training, I'm a biochemist, and I currently work as a quality engineer, and I love science. I enjoy encouraging young boys and girls to go into areas of science by mentoring and tutoring. I enjoy tutoring science, and I enjoy tutoring chemistry. Today, I am going to demonstrate the physics behind something we're all familiar with. A fidget spinner. A fidget spinner works because of its unique design. The weights spin in unison around a central bearing. So you may be asking yourself, well, why does it spin? Why does it spin so long? And why doesn't it stop midway when I try to flip it over? But before we get started with any experiment, we have to think about safety first. And although this is a pretty safe toy, we want to use our personal protective gear today. And that will include goggles. I think we're ready. For today's demonstration, you will need a fidget spinner, a pencil or chopstick, 12 inches of string, and some tape. So to begin our experiment, we're going to create and make a loop at one end of your string. So we have our string here, and we're going to make a small loop on it on one end of the string. See that there? We have a small loop. And then on the other end of the string, we're going to attach it to the end of this table here with our tape. Now that our string is nice and secure, we're going to insert this pencil in the middle of that loop. And we're going to tighten it to allow about 1 inch from the end of the pencil. So we have our pencil and we have our loop, and it's attached to the table. So here we have our string, it's attached to the table by tape, and we have our pencil that is secured by the string with 1 inch remaining on the edge. Then for our fidget spinner, you may have to remove the cover of the fidget spinner to expose the inner bearings of the fidget spinner. Now we're going to hold our pencil parallel to the floor, just as we're doing here. And we're going to insert the center bearing on the pencil. So what do you think will happen if I put this fidget spinner on this pencil and begin to rotate it and spin it? Do you think the fidget spinner will fall? Do you think the pencil will fall? Do you think the tape will break? Well, those are all great questions. Let's check it out. Now, what just happened there? So what did you observe? Did you notice how the fidget spinner continued to spin as the pencil began to rotate? Well, this is called gyroscopic precession. It happens when a spinning object rotates on an axle. The rotational force of the fidget spinner is pushing outwards on the axle. In this case, the axle is the pencil, which is suspended and begins to rotate in a slow circular motion. This happens when our bike remains upright and moving forward at the same time. This is the same force that causes us to put our feet down in order to stop and remain balanced on the bike also. Well, that's the end of today's demonstration. Be sure to remove your tape from your table and put away your materials. Also, think about ways you can modify this experiment. What do you think will happen if you lengthen the string? How about if you spin the fidget spinner at a slower rotation? If you have an adult at home. They can even help you perform this experiment using a bike wheel and some rope. Well, I hope you had fun today, and I hope you learned something new. Once again, my name is Tesha Dampier, and thanks for watching Science at Home.